While we contemplate stars, we likely envision small glittering objects in the nighttime sky. At the very least, this is how we perceive them from down here on the planet. However, stars are quite different. For instance, one of the largest stars, Betelgeuse, is considerably bigger than our Sun. For many years, this star has puzzled researchers, but recently, more unsettling phenomena have been occurring with Betelgeuse, causing scientists and other knowledgeable individuals to become very, very worried. Join us in this video as we delve into the fascinating information about Betelgeuse, its anticipated demise as forecasted by the James Webb Telescope, and how this recent development may influence our galaxy and our existence right here on Earth. As described by physicist Michio Kaku, Betelgeuse is a cosmic marvel, a massive star that has captivated astronomers for a long time. A Greek astronomer named Timocharus was the first to identify it. This star is so enormous that it can be seen in the nighttime sky from Earth, especially during winter. If you're interested in constellations, you've probably noticed or heard of this star. It is the reddish-orange star that designates the upper left shoulder of the Orion constellation. Thus, this star is ancient and currently one of the brightest stars in the night sky. One intriguing aspect of Betelgeuse's brightness is that it does not remain steady. Instead, it fluctuates. This variation is one of the distinctive features of this star, but it isn't the only one. Let's examine some of Betelgeuse's specific characteristics. Most of the stars you observe in the night sky are actually far from Earth. The closest star is 4.2 light-years away. If you're uncertain how the term light-years defines distance, picture moving at the speed of light for an entire year. It has been demonstrated that light can traverse a distance of 186,000 miles per second. Thus, the distance light can cover in a year equals 1 light-year, which results in billions of miles. So, when we say the nearest star is 4.2 light-years away, it signifies that it is billions of miles from Earth. But guess what? Some stars are even farther, and Betelgeuse is one of them. Betelgeuse is located roughly 600 light-years away from Earth. Therefore, if you were to travel to it at light speed, it would still take 600 years. We cannot move that quickly. Not even our fastest spacecraft can. Yet it still shines brightly in our sky. If you're curious how Betelgeuse can be so luminous despite its distance, it's due to its other qualities, such as size and brightness. Betelgeuse is about 500 times larger than our Sun, and its radius is estimated to be about 1,000 times that of the Sun. It is so vast that it appears as a disk in space when using advanced telescopes, while other stars appear as tiny points of light. This disk appearance is thought to be an effect of reactions occurring in the outer layers of its atmosphere. In terms of mass, Betelgeuse measures approximately 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers, equal to 2 times 1, 0, 30, 2 by 10, 30 kg. Scientists cannot ascertain the precise mass of Betelgeuse because there are no other planetary bodies orbiting it for comparison, and of course we cannot measure it directly from our planet. However, it has been established that this star is at least 12 times more massive than our Sun. The brightness of Betelgeuse varies from a magnitude of +0 to +1.6. In more familiar terms, Betelgeuse is 16,000 times brighter than our Sun. No wonder it was nicknamed a red giant. Nevertheless, the brightness of Betelgeuse is not consistent. It fluctuates due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it becomes brighter, but when it contracts, it dims. This cycle can last from 10 to 100 days or even longer. One unique trait of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field in these areas is much stronger than at the standard surface. However, the downside is that these strong magnetic spots hinder the flow of hot gas to the star's outer surface, causing the star to be cooler in those regions. The fact that Betelgeuse possesses many more of these spots compared to our Sun accounts for why it is cooler than our Sun, despite its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and significantly more numerous. To give you an idea, the spots on Betelgeuse can be twice the size of Earth. Betelgeuse also features a magnetic field that is 1,000 times stronger than that of the Sun. This field is why, when viewed through a telescope, the gases on Betelgeuse's surface appear to form loops or arcs. Betelgeuse has a surface temperature of about 3,500 Kelvin. This low temperature contributes to the diminished energy emitted by the star and its faint red hue. Betelgeuse is a red star, but it wasn't always red. It was yellowish approximately 2 million years ago, similar to our Sun. Over the years, its color began changing to orange-red, and around 2,000 years ago, it gradually started becoming the red star we recognize today. This fact has led scientists to believe that the star is aging. Betelgeuse emits as much as 7,500 times more energy than the Sun, making it a formidable counterpart to Earth's Sun if it were not so distant. The reality that Betelgeuse, which is 600 light-years away, can still be seen and identified with the naked eye at night is quite extraordinary. Our Sun is merely 8.3 light-minutes from Earth, which is why it is so powerful. If Betelgeuse were slightly closer, we would also be able to see it during the daytime. However, if it were to replace the Sun, it would engulf or displace Earth and the other four nearby planets due to its immense size. Furthermore, even if it could match the Sun, it emits more radiation than our Sun. That alone could render it a poor sun for Earth. So perhaps it was never meant to be our Sun. Just a distant, large red star that we can admire and study from afar. The red light from Betelgeuse is even more pronounced because of its distance from Earth. One aspect of the universe is that it is continuously expanding. This expansion alters the light rays from objects and galaxies, causing only longer light wavelengths to travel farther. Red light has a longer wavelength than blue light, so at great distances, blue light will not be visible, only red light. But as charming as Betelgeuse has been all these years, one thing remains clear. It is an ancient star nearing the end of its lifespan. Stars become red toward the end of their lives when the hydrogen in their cores converts into helium through nuclear fusion. At this stage, the star gradually transforms into what space experts refer to as a red giant. From what we know about stars, massive stars age more rapidly than lighter stars. Since Betelgeuse is approximately 12 times more massive than the Sun, it is dying at an accelerated rate. Additionally, this star's irregular pulsations and brightness are further strong indicators that it is perishing. Betelgeuse began dimming in 2019, but the lowest brightness ever recorded was in February 2021. This was when worries about the star's near-death state started to grow within the scientific community. But wait a minute, how do stars die? Well, they explode, an event scientists term a supernova. So what is a supernova? If you've ever witnessed a nuclear explosion, know that it pales in comparison to a supernova. A supernova is a colossal and powerful explosion that occurs when stars reach the end of their existence. An immense amount of energy is typically released into space whenever a supernova occurs, making these events some of the universe's most brilliant and awe-inspiring occurrences. However, there are two types of supernovae, Type 1 and Type 2. A Type 1 supernova occurs when a remnant of a low-mass star gathers matter from a companion star until it reaches a critical mass it can no longer sustain. This triggers a nuclear reaction, resulting in the star's explosion. A Type 2 supernova happens when high-mass stars like Betelgeuse deplete their fuel and can no longer support their own structure. Consequently, the star detonates, releasing an enormous amount of energy. A typical Type 2 supernova will emit light, heat, and radiation. They can be so powerful that they can obliterate everything in their path. At times, a Type 2 supernova can emit light so bright that it overshadows all the other stars in its galaxy. Type 2 supernova explosions also generate heavy elements like iron, nickel, and gold. These metals are created during the high-pressure and high-temperature reaction and are scattered into space as the star explodes. As they enter space, they contribute to the formation of new stars that will emerge from the supernova. Supernovae generally result in the creation of new stars or planets. Thank you for your patience. Here's the continuation. If it speeds faster than light, or possibly the shockwave may reach us sooner than anticipated due to unforeseen factors. In any case, while scientists and astronomers may have differing views on the potential danger posed by Betelgeuse, one thing remains certain. The universe is full of surprises, and our understanding of it is constantly evolving. So is the possibility of Betelgeuse going supernova good news or bad news? It's challenging to say definitively. On one hand, a supernova event could be a dazzling astronomical spectacle potentially visible even during daylight hours. On the other hand, the repercussions for life on Earth could be catastrophic. Ultimately, it serves as a reminder of the vast power and unpredictability of the cosmos and the importance of ongoing scientific exploration and understanding. Whether Betelgeuse's fate will directly influence us or not, its story provides a fascinating glimpse into the mysteries of the universe and our place within it. Following its explosion, Betelgeuse may trigger the spontaneous formation of another star. Capella is only 43.3 light-years away. If a star like that were to be activated, Earth would certainly suffer from the aftermath. So let's assume we are safe from the blast and it doesn't reach us. What other effects could we experience from Betelgeuse's explosion? Primarily, it would involve light effects. A supernova mainly releases light and energy, so if Betelgeuse exploded, you would witness its brilliant light in the sky wherever you were in the world. As we ponder the vastness of space and the celestial entities that inhabit it, Betelgeuse stands out as a star of extraordinary size and complexity, located about 600 light-years away from Earth in the Orion constellation. Betelgeuse, also known as Alpha Orionis, has captivated the imagination of astronomers and stargazers for centuries. Its distinctive reddish-orange hue marks it as a prominent member of the night sky, visible even to the naked eye during certain times of the year. The sheer size of Betelgeuse is astonishing, roughly 500 times larger in diameter than our Sun, with a mass estimated to be between 12 to 19 times that of the Sun. Betelgeuse is classified as a red supergiant, a classification that places it among the largest known stars in the universe. Its immense size is not merely a matter of scale. It also has profound implications for its life cycle and ultimate destiny. Stars like Betelgeuse are born from vast clouds of gas and dust that collapse under their own gravity to form dense cores over millions of years. These cores heat up and commence nuclear fusion, converting hydrogen into helium and releasing tremendous amounts of energy in the process. This fusion process supplies the energy that sustains a star throughout its main sequence phase. However, Betelgeuse has already depleted much of its hydrogen fuel. Like all stars, it is in a constant struggle between the inward pull of gravity and the outward pressure generated by nuclear fusion. As hydrogen fusion decreases in its core, the balance shifts, and the star begins to evolve, expanding outward and becoming cooler and redder, a transformation marking the onset of its transition from a main sequence star to a red giant. The evolutionary trajectory of Betelgeuse is characterized by its irregular pulsations and variable brightness. These pulsations stem from complex interactions within its atmosphere, where energy generated in its core travels through layers of gas, causing them to rhythmically expand and contract. This variability in brightness, known as its light curve, can last from weeks to months. For astronomers, studying these pulsations provides valuable insights into the internal structure and dynamics of massive stars approaching the end of their lives. One of the most intriguing aspects of Betelgeuse is its tendency to undergo sudden, dramatic fluctuations in brightness. In late 2019 and early 2020, astronomers observed unprecedented dimming episodes, where Betelgeuse's luminosity dropped to levels never before recorded. These dimming events ignited speculation and debate among scientists regarding the underlying causes and potential implications for the star's future. One hypothesis proposed to explain Betelgeuse's recent dimming episodes involves the formation of large, dense clouds of dust and gas in its outer atmosphere. These opaque clouds could temporarily obscure the star's light as they drift across our line of sight, resulting in the observed dimming. Another theory suggests that the dimming may be connected to fluctuations in the star's internal processes, such as variations in convection or pulsation activity. Despite these episodes of dimming, Betelgeuse remains a beacon in the night sky, visible to observers on Earth as one of the brightest stars in the Orion constellation. Its luminosity, combined with its colossal size, makes it a celestial wonder and a target of intense scrutiny for astronomers seeking to unravel the mysteries of stellar evolution and cosmic dynamics. Betelgeuse's future, however, is far from certain. As a red supergiant nearing the end of its life, it faces an inevitable fate shared by all stars of its kind: a spectacular finale in the form of a supernova explosion. Supernovae are among the most powerful and energetic events in the universe, capable of briefly outshining entire galaxies and producing vast amounts of heavy elements essential for the formation of new stars and planets. The prospect of Betelgeuse going supernova has captivated both the scientific community and the public alike. While astronomers have long anticipated such an event, predicting when it will happen remains challenging. Supernovae are notoriously unpredictable, with the timing of each event dependent on a delicate balance of factors, including the star's mass, composition, and internal dynamics.